Question is again of Irodo. It's a very beautiful question on kinematics, where again you use the concept of vectors, just like a previous video of ours, where we discussed about a cone rolling around about a vertical axis. Okay, it's similar kind of question. Let's look at the question first of all. A solid body rotates with a constant angular velocity omega naught equals to zero point 0.5 radians per second about a horizontal axis AB. At the moment t equal to 0, the axis AB starts turning about the vertical with a constant angular acceleration beta naught at that is zero point 0.1 radian per second square. Find the angular velocity and angular acceleration of the body after t equals to 3.5 seconds. So first thing, given data I have written here. Second, they have not given us which body is rotating. Body shape is not specified. Is it a sphere? Is it a disc? Is it a cylinder? Nothing is mentioned. So for my comfort of diagram and all, I have chosen a disc. I could have taken anything, right? So there's a solid body. The disc is my solid body and it is rotating about an axis AB like this, right? And this AB axis is further revolving around another axis, a vertical axis. So this is what the question is saying, and this omega naught is the velocity with which that body, solid body, in our case the disk, is rotating. So can I say that this omega can be considered as a omega, that is a rotational spin rotation, right? Spin omega. So if I want the omega to be in this direction, I'm assuming that omega naught is in this direction, then how should the omega, the rotation direction, be? So I'm finding that it should rotate in this way. So my disk is actually rotating in this way, and because of this rotation I'm having an omega naught in that direction, plus it is accelerating, and I want this disk, let us say this is the axis AB, I want the AB to be rotating like this. I want it to move in this way. So when I see from the top, when I see this rotation from the top, what kind of rotation I'll see? I'm seeing it as a clockwise rotation from the top. As an observer from the top, if I see, I'm finding this as a clockwise rotation, right? All right. So if it has to move in clockwise, initially it was stationary. The AB was not revolving. At time t equal to 0, it starts revolving. That means the acceleration beta naught should be in which direction? That's another question. If it has to have finally velocity in this way, so if it is going to rotate in this way, that means the omega should be coming inside. So I can say a new omega would be created in this direction. What is this omega? This is omega of revolution, that is omega of spin, right? Like the two omegas, previous video we have discussed that. And acceleration would be also in the same direction, beta naught, because at time t equal to 0 there was no acceleration, no omega. Beta naught is 0 at time t equal to 0, and omega is 0 just before at time t equal to 0. Then at time t equal to 0, AB starts revolving, so suddenly this omega comes. And why this omega came? Because of this beta naught, because now AB is revolving with a constant angular acceleration of this much. Now after some time t, we have to understand, after some time t, what will be the magnitude of omega naught? Omega naught is constant in the question they have said, so magnitude of omega naught will remain same. What will happen to omega? Omega is the angular acceleration created, sorry, angular velocity created because of this angular acceleration. So this omega will keep changing, and that can be obtained by a simple formula: omega equals to omega naught plus alpha t. This omega is the final, this omega is the initial. The final omega, we are calling it as omega. The initial omega here was 0 because AB was not revolving at that time. But 0 plus alpha is basically our beta naught, right? And that beta naught is 0.1 into time at which I want is 3.5. So I'm getting this omega as 0.35 radians per second. So if I take at this moment time t equals to 3.5 seconds, my body, that is the solid disk that is rotating, has a two omegas. One is the omega naught because of its spin, another one is omega because of its revolution. So two omega. So if you ask me what is the total omega at the time t equals to 3.5 second, then we can say at t equals to 3.5 seconds, we can say the total omega, that is would be equal to, magnitude wise I am saying, would be under root of omega naught square plus omega square. This would give me under root of omega naught is nothing but 0.5 square plus 0.35 square. And solving this, what do we get? We get the value to be 0.61 radian per second. This will be the total omega that I'll be getting. So if you are interested in seeing what's happening at that time t equal to 3.5 second, means I am having this omega as 0.35 radians per second, and at that time the omega naught value is the same, 0.5 radian per second. And finally resultant of both of them would be in this direction, which will be some omega t, the total. And this value we got it as 0.61 radians per second, like this. Okay, but the question is not over. What is the next thing that they want? They're asking also find the angular acceleration of the body after t equal to 3.5 second. Now if you are interested in finding the angular acceleration, okay, then we have to understand that we already have an angular acceleration of beta naught, and that beta naught is responsible for creating the omega, right? But we are also having one more angular acceleration, and that would be because of the change in direction of omega naught. So two angular acceleration we'll be having, and if we are interested in finding the new angular acceleration, we have already done this in the previous video. What we can do is, I'll take the top view. Let us take the top view from here as an observer. If I view, what do I see? So I'll be seeing that initially the omega naught was in this direction at some moment of time. After a small duration of time, the omega naught vector, the vector of omega naught, has rotated by a small angle of d theta, and it has reached here. It has reached at that point. So what's the magnitude of the vector? Magnitude is the same, omega naught, but it has got rotated. So that's why this would be considered as the d omega, the change in omega that has happened. Now, how can we get this d omega? Because the angle d theta is very small, and because these two vectors are having same magnitude, I can say that this line is nothing but an arc. And if we use that concept of arc length, we can say d omega arc length is nothing but omega naught into d theta. That's it. Okay, see, I told you when I look at from the top how the AB would be rotating clockwise. So same thing, this omega naught vector actually is in the direction of AB, and that AB is rotating like this in a clockwise direction, right? Okay, so this is how it is rotating. All right, fine. So now this is d omega. I'm interested in finding the acceleration, angular acceleration, which I can obtain by doing what? D omega by dt, differentiating. Omega naught being a constant value, we won't be differentiating that. What remains is d theta by dt's differentiation. So now d theta by dt, the rate of change of my theta is in that omega, this omega. Isn't this omega responsible for that rotation, the revolution of AB? And that revolution is responsible for d theta, right? So when I find out d theta by dt, I am basically finding out that revolution. Okay, and this d omega is the change in which omega? Omega naught, right? So let me call it as d omega naught, so that later you should not have any confusion. So d omega naught, the variation of d omega naught would give me the acceleration, angular acceleration of that. So now I am having how many angular acceleration? Number one, I have beta naught. what is the purpose of beta naught? Beta naught's purpose is to increase the omega. And what is omega? Omega is the revolution angular velocity. Now, what is the purpose of beta here? Beta has nothing to do with the change in omega. The beta's purpose is only one. Beta will be changing the direction of my omega naught. That is the spin angular momentum. This spin angular momentum's direction is keep on changing. So that is being controlled by the beta. Beta is responsible for that. So from here, can I obtain the value of the beta? How much would that be? Omega naught value already I know. It's a constant value, 0.5 radians per second. Now omega value also I need, but omega is a continuously varying function. So the thing is, in question they're asking me both the omega total and the beta total at a specific time, that is 3.5 seconds. So that means I have to use this omega also at 3.5 seconds. Okay, so I am saying that at t equals to 3.5 seconds, my beta is equal to 0.5 into what I am having there is 0.35 radians per second. Okay, so this finally gives me what value here? I'm getting it as 0.175. Okay, 0.175 radians per second square. Okay, like this I'm getting finally. Okay, sorry. Yes. Now, once I get this value of beta, now let us find out the direction of beta. So what is the direction of beta? Beta naught is in this direction because it is supposed to be accelerating the omega, so they have to be in the same direction. Now, the beta is responsible for the d omega. So you have to check which direction is the d omega at this moment. So my AB is going to revolve in this way. Because of this revolution, only d omega happening. So d omega at this moment is outwards like this, right? So if here I see the d omega is downwards and beta is responsible for the d omega, so beta should be in the direction of d omega. If that is the case, here which direction the disk is now moving? It's coming out, right? So d omega is going to be in this direction, so that means my beta should be also coming out of the board, beta. So now you tell me, what is the angle between the beta naught and beta? Always it will be 90 degree. So at this moment of t equal to 3.5 second also, it will be 90 degree. So if you're interested in finding the total beta, it will be nothing but b total is equals to beta naught square plus beta square. That's it. So now beta naught square, beta naught value, how much we are having? 0.1 square plus beta, how much we found out? 0.175 square, and this value on calculation we are getting how much? 0.2, roughly 0.2 radians per second square. Like this we'll get. I hope all of you are able to understand the concept here, right? So we have already discussed earlier in the previous case or previous question of that cone revolving in the vertical, about a vertical axis. Same concept is here with one small addition. In that vertical cone revolution, we didn't have a extra angular acceleration. Here we are having this beta as an extra angular acceleration. Oh, sorry, not beta, the beta naught, that is there as an extra angular acceleration, because the omega with which the disk is rotating, in my assumption the disk, that omega is continuously changing. This omega is not constant. Beta naught is responsible for that. Other than that beta naught thing, other than this calculation using the beta naught, everything else is exactly similar to the previous Irdo question that we have discussed. So I'm hoping that you have understood all this. If you have any doubts or confusion, please make sure to comment. I'll be replying to that. Okay, thank you.